Moving on to the second part of the video, which is part B, and part B has also four questions, which is entitled Similarity and Dissimilarity in Feedback. So moving on to question number 5, which is missing data, noise, inconsistency, and fixes. Feedback summarization faces three major issues. Missing data occurs when students skip question, which can fix this using imputation such as replacing missing values with mean or class-based estimates. Noise refers to random and accidental errors like mistyped rating or extreme outliers. We handle noise using smoothing, binding, and outlier detection. And inconsistency happens when different surveys or entries contradict each other, like giving different ratings for the same question. And we solve this through data cleaning rules and cross-checking entries. Always remember, clean feedback leads to reliable analytics and better academic decisions. That was question 5. Question number 6 includes normal distribution, properties, and z-score. The normal distribution is one of the most important concepts in statistics. It is a bell-shaped, perfectly symmetric curve centered around the mean. In a normal curve, the mean, median, and mode are all equal. Most data points lie close to the mean and very few occur in the tails. It follows the famous 65, 95, and 99.7 rule. About 68% of the data lies within one standard deviation of the mean, and the 95 within 2, and almost all within 3. The z-score converts any value into standard units by subtracting the mean and dividing by the standard deviation. Once data is converted into z-scores, it follows the standard normal distribution, which has a mean 0 and standard deviation 1. That concludes question number 6. And now question number 7, which includes stem and leaf plot, box plot, and quartiles, which is equivalent to question number 1 and 3. In this question, we take the given 20 feedback values and summarize them using two visual techniques: a stem and leaf plot and a box plot. A stem and leaf plot is a compact way of showing each data point. We split each value into stem, which is leading digit or digits, and a leaf, which is the final digit. Let's see the distribution while keeping individual values visible. Next, we construct the box plot. For this, we sort the data and find question number 1, the lower quartile, question number 2 is the medium, and the upper quartile. The box spans from question number 1 to 3, and the whiskers extend to the minimum and maximum values that are not outliers. The plot highlights the spread, symmetry, and any potential outliers in the data set. Together, both methods complete complete a picture. Like stem and leaf shows exact values, while the box plot summarizes overall structure. Now that was question number 7. Now heading on to question number 8, which is the last question of part B, which includes bar chart, radar chart, and satisfaction interpretation. In this question, we have 5 feedback attributes rated by 12 students. First, the bar chart helps display attribute-wise performance, which each attribute we plot the ratings on the y-axis and the frequency or score on the x-axis. This is ideal for spotting which attributes scored high or low. Next, we draw a radar chart. Each axis represents an attribute from A1 to A5. For each student or for overall average, we connect the points to create a shape. A larger, more balanced shape indicates more positive and consistent satisfaction. Finally, we interpret the results, identifying uh, interpret the results, identify which attributes students like the most and which one need improvement, and whether satisfaction is consistent across attributes. This creates a quick visual summary for faculty. That was the end of part B, which is similarity and dissimilarity and feedback. That is the end of this video.